students, welcome to e-learning. We are going to continue with the shear force and bending moment. So in the previous video we have learnt types of loads, types of beams. Today we are going to continue with beams in bending, how they have sign conventions, what are the symbols used in the calculations, what are its units used. So both shear force and bending moment are vector quantities requiring a sign convention of signs, in order that values of opposite sense may be separated. Mathematically, signs are chosen since it is in calculation problems that it becomes necessary to use such a convention. So here one table which is showing us the load effects, shear force and bending moment. Symbol for shear force is used as Q, V or S. For bending moment it is M. So there are few people use positive signs in positive column, which is shown for shear force. These signs are used, and some people go for reverse of it. It is own choice one can make for understanding positive and negative shear forces and positive and negative bending moments. Some signs are here. Sign conventions are just used to differentiate between the plus, positive and negative. So here unit for and also these sign conventions you will get to know clear while solving the problems, because there is one example further in the slide which is going to help you how to use this sign convention. These are not fixed sign conventions. You can go for your own choice or reverse it exactly what is mentioned in the table here. So it is not compulsory that you have to go for the same sign conventions. So the shearing force at any transverse section in a loaded beam is the algebraic sum of the forces acting on one side of the section. This is nothing but the shear force definition, and as it is said to be algebraic sum of all the forces acting. So whatever the forces are acting, whether it is action or reaction forces, we have to consider them, but we have to see that you have to start, or you have to take only one side of the section. So here you can see working to the left here, this qx is nothing but the shear force left of the x section. So this is nothing but the x section taken vertically like this. So you can come across how it is taken. So here they have taken the left force, that is reaction force Ra, which is acting upwards as positive, and minus V1 is acting downwards, minus V2, minus V3. Then further they are not going beyond x section, right? So only the left part of the section x they have taken. So here the sign conventions are exactly opposite, which is mentioned above in the previous slide, right? So you can go through, and also the moment which is calculated here, moment at x, and here again they are taking with left of x, okay, working to the left of x. You should not come on the right side of the x section in calculation of this type. So here you may come across moment is what? Force into perpendicular distance normally. So it is said to be algebraic sum of the moments about sections of the all forces on one side of the section. So you can see Ra into A is mentioned, So till section X, distance is A and force is RA. So RA into perpendicular distance. So this is perpendicular distance. You can take it down. So it is taken to be positive. It means it is clockwise moment, right? So RA into A distance, perpendicular distance. Now coming to moment of downward forces acting. Reaction is completed. One force is complete. Second is V1 into A1, because this is going to act in downward direction and it is going to rotate in anti-clockwise direction with respect to X. So the distance, perpendicular distance for this V1 force is A1 here, right? So it is acting in anti-clockwise, so it is taken to be minus V1 into A1. Similarly, V2 is also acting in anti-clockwise, so minus V2 into A2 till X section. Similarly, V3 into A3. So beyond X, it is not taken. So this is the moment calculation example. If you are working, or if you are working in shear force and bending moment calculations, if you are working on the right side of the X, okay, you have to be careful that the sign conventions will be exactly opposite to working of left of X. Okay, so coming back to working to the right of X, shear force at X. So this is the section. If you want to take the shear force at X, see that reaction is acting upwards, right? Reaction B is acting upwards, so they are taking minus sign there. Okay, and downward force beyond X, it is positive. So minus RB plus V4. So shear force is only algebraic sum of all the forces acting in upward or downward direction. So now coming to moment at X, but we are working to the right of X. Okay, to the right of X. Here this RB is going to rotate in anti-clockwise direction with respect to X, right? So here the sign convention is exactly opposite. So you can see anti-clockwise moments were taken minus, but here it is plus RB into B, because perpendicular distance is B here, correct? So RB force into perpendicular distance till X. So this is the perpendicular distance here. So then next force is nothing but V4, which is acting in clockwise direction, and its perpendicular distance is A4, right? So V4 clockwise direction on the right side of the X, so it is taken as minus, negative. So minus V4 into A4. So this is how the pattern goes in all the analysis of beams. So shear force, in calculating shear forces, in calculating bending moments, whether it is cantilever beam, whether it is simply supported beam, whether it is overhanging beam, whether it is continuous beam, whether you are finding shear forces, bending moments. Okay, so thank you students. So you can come to the next slide. Things to remember for drawing of shear force and bending moment diagrams. Okay, so these are the some important points to remember. If you get confused when you draw, or if you are if the concepts are not clear, these points are going to help you very nicely to draw shear force diagram and bending moment diagram. Start from right hand section. Okay, I follow right hand section, that is to the right of X, just now what we discussed. Use sign conventions of the side which you are choosing, that is right or left. Fix one sign convention for your calculations. If the thing are complicated, use other side of the section. If you feel that the calculation is going tough, you can change these others, change the section or the calculation part to the right or left and go further. Start from 0 and end to 0. That is, bending moment at the ends will be always 0 in simply supported. So end point of shear force, end point of shear force will be equal and opposite to the reaction at that point. See, end point of the shear force will be equal and opposite to the reaction of that point. It means if the reaction is acting upwards, always reactions will be in reaction forces will be acting in upward direction. So the downward forces which are acting give shear forces equal. So coming to next point, mark the points and draw the diagram considering the type of load, whether it is point load, whether it is uniformly distributed load, etc. At the change in nature of forces, there will be 2 points in shear force diagram. Okay, change in nature of forces, there will be 2 points. Change in nature of forces in the sense the sometimes when you come across combined forces, point load as well as UDL. So this you need to keep in mind that there will be 2 points in shear force diagrams. Okay, at that particular section. Then at couple, there will be 2 points in bending moment diagram. Okay, there will be 2 points in bending moment diagram. Couple in the sense it is nothing but a moment you can consider. Okay, beams are assumed to be always straight, horizontal, uniform cross section and structure unless otherwise specified. Always it is assumed that the beams are straight, horizontal, because we know the casting or the molding of beams will be exactly in orthographic, you can say, right? Orthographic, that is LBD, all the 3 axes X, Y, Z is considered here. Self weight of the beam neglected unless its definite value is given. Self weight is neglected. Okay, just the live loads which are acting are considered. Shear force may be maximum at supports. Okay, normally it will be or under point loads or where shear force is 0, where bending moment may be maximum. When shear force is 0, bending moment will be maximum, and when bending moment will be 0, shear force will be maximum here. Okay, so this is the point to be remembered. These red color points are very important. Where the bending moment changes its nature is known as point of contraflexure. In bending moment diagram only, when the bending moment drawing changes its sign from plus to minus, positive to negative, that intersection of the change of the diagram, that point is called as point of contraflexure. Okay, so this is very important. So coming to the next slide, so we will continue in the next video. Thank you students, and for further notification and upcoming videos, please subscribe the channel, like, share, comment. Thank you.